everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. We've spent several videos building up the foundations. We've talked about endogeneity, reverse causality, instruments, relevance, exclusion. Now we finally answer the practical questions. How do we actually use an instrument to estimate a causal effect? The answer to that is two-stage least squares. And we will also write it as 2SLS for abbreviation, but again, this is two-stage least squares. But before the mechanics, let's understand what it's doing and why it's doing that. The first thing, we need to clear up some terminology. Because that's where a lot of students start to get confused. The first distinction is that you'll hear, whenever you talk about instrumental variables, either IV as the method or 2SLS as the method that is being used, okay? Keep in mind, instrumental variable is the general idea. Using an instrument to isolate clean variation in X. So it's a concept, a strategy, an approach. The 2SLS is the specific estimation procedure. Okay. So it's the most common way to implement IV in practice. So when people say, I ran an IV regression, they almost always mean that they have used 2SLS. So the terms are often used interchangeably, but strictly speaking, IV is the idea that 2SLS is the method, okay? Keep in mind, on top of 2SLS, there are also either IV type of estimators, such as the LIML or the GMM. But 2SLS is definitely by far the most common in applied economics. So for these videos and this series, when we say IV estimation, we will really mean 2SLS. In some textbooks or lectures, you will refer to IV as like the 2SLS estimation with only one instrumental variable and one endogenous variable, while 2SLS is the most generic with as many instrumental variables and as many as endogenous variables as possible. But keep in mind that is at the discretion of your lecturer. Most of the time, the IV itself is just a strategy, the approach, and it uses 2SLS as the specific estimation procedure. Now, let's go back and recall the problem. We want to estimate y equals to b0 plus b1x plus an error term u. And we know that the covariance between x and the u term is definitely not zero. So x contains contaminated variation. Let's say education contains variation driven by ability, family background, motivation. And there is also reverse causality because expected earnings influence schooling decisions. And OLS would pick up all of this. So we would get biased estimators, okay? Estimates. Now, what we really want is that we don't need all the variation in X. We only need the part of X that comes from the instrument, okay? So once again, X, there's clean variation plus contaminated variation. And we are interested only in the clean variation, and the 2SLS uses the clean part to estimate the beta 1. So how does it do it? How do the two stages really work? the first stage, which is also your step one. I'm gonna write it here, step one. You'll see why I'm writing it into steps. In stage one, we run a regression of the X variable on the instrumental variable. So in this case, this is going to be X equals to pi0 plus pi1 Z plus an error term. And whenever people refer to stage one, what that means is that you actually have to run this regression, to run an OLS. And that's the whole reason why I'm including those step one and so on. So in stage one, the first step is like you come up with the idea that you need to run a regression of X on Z. Step two would require to estimate it, which means that we're going to get X hat equals to pi0 hat plus pi1 hat Z. And keep in mind, this is done through OLS. So that is the first OLS regression that we're running at this point, okay? Keep in mind, the first stage, what it's doing at this point is asking the question, how much of the variation in X can be explained by the instrument? So if we put a little bit of context with the examples that we've had so far, is how much variation in X or education, for instance, can be explained by the variation in your Z variable, which we mentioned in the previous video could be distance to university or distance to school, okay? And the answer to this question, if I put a big Q here, the answer would be given right here. It's this X hat, okay? So the predicted values of X contain that information. So everything else, ability, motivation, family background, that is left in the residual in here, the epsilon. X hat has been purified of these influences. Now, why are they so special? Keep in mind, X hat is special because of where the variation is coming from. It varies only because the instrument Z varies. And if Z satisfies the exclusion restriction, if a Z is uncorrelated with the error term, then X hat in here is also uncorrelated with the error term, okay? So if Z, let's say, covariance between Z and the initial error term is equal to 0, that means that the covariance of X hat and the U is also equal to 0. Okay, so the contaminated variation has now been filtered out. Let's move to stage 2 of the 2SLS. We need to run the second regression. In the second regression, we have Y being equals to B plus B1. And now we're going to add not the X, but the X hat, the one that is uncontaminated by other variables, and then plus a error term U here, okay? So this would be, let's say, step 3. And in step 4, again, what you're doing, you're actually estimating it through OLS again. So this is your second OLS regression, in which case you're going to get Y hat equals to beta 0 hat plus beta 1 hat. I'm going to put IV in here because this is ultimately the beta IV you were looking for, okay? Or the beta 2SLS, whatever you want to call it, X hat, okay? So you're not, again, regressing the Y on actual education, which isn't contaminated, but you're regressing it on predicted education, which is clean. It's important to notice that in practice, you never run these two stages manually, either in R or in Stata. The software does it correctly in one step. Running them manually would give you the right coefficient, but also wrong standard errors. So just be very mindful whenever you're working and implementing these actual steps and stages into actual software. Okay. Now, what is the core intuition? The OLS, what it's doing, the OLS asks what happens to income when education changes, okay? Instead, 2SLS asks what happens to income when education changes because of the instrument. And that's a fundamentally different question. And that's a right question to ask when X is known to be endogenous. This is also why the 2SLS estimates sometimes are called local effects. Okay, because they capture the effect for the people whose education actually changed because of the instrument, not just everyone. So just those who were affected by Z. And earlier in this series, we studied all the Frisch-Wallovel theorem, which showed that OLS isolates beta 1 by removing the influence of other variables, partialing out contamination. So what 2SLS is doing is something structurally similar, but instead of removing the contamination, it is actively selecting only the clean variation. So if we were to make a comparison with the Frisch-Wallovel, the Frisch-Wallovel removes what you don't want, while the 2SLS procedure in here, it's keeping only what you trust. Because at the end of the day, you still need variation to explain why your Y is varying. So both are about identifying the right variation. Is just the Frisch-Wallovel works when you have all the relevant variables. 2SLS works when you don't, but you have an instrument instead. I hope this was helpful. So now you have the full steps and stages for the 2SLS. Stay tuned because in the next video, we're going to make a comparison between OLS and 2SLS so that you can see which one is preferred to which method and when, and also a more general version of the 2SLS step procedure. So stay tuned and I'll see you in the next video.